Okay guys, I think I should be live. Uh, just making sure my code works and my audio is visible or audible. Sorry about that. And I believe you could see some of this code, which is HTML. This is not the purpose of this live stream, and this live stream is about Docker and Kubernetes. So what I'm going to be doing is I'm going to create a folder, and I'm going to make sure that I have all this installed, and I'm going to follow this complete learning path through AI. So what we're going to be doing is, first of all, we're going to create a folder here. Suppose I go into my folders, and in my new folder, so I'll just rename this to, let's suppose, um, so we'll do F2, and we'll say that was Docker, okay, and Kubernetes. So Kubernetes, like this, and this is our folder. So let's just add a brand new slate. Let's just cross all these instances out. And what we're going to do is I'm going to say cmd, and we're going to have code and dot. So you can see over here we have this folder, and we have a nice new folder. Let's go back here in AI. So I wrote a prompt here, but before that, let's see what Docker is. So what is Docker, right? So Docker is basically a set of platform as a service products that use OS level virtualization to deliver software in packages called containers. The service has both free and premium tiers. The software that hosts the containers is called Docker Engine. It was first released in 2013 and is developed by Docker Inc. So the programming language written for this was Go, and was initially released in 2013. The purpose of this is basically to package things. Platform as a service product that uses OS level virtualization to deliver software in packages called containers. So you basically have software in packages. The service has both free and premium tiers. The software that hosts the containers is called Docker Engine, and the first release was in 2013. So let's go ahead and see. Mastering Docker and Kubernetes on Windows 11 involves understanding how containerization and orchestration work, and learning how to use these tools effectively for deployment, scaling, and managing applications. Here's a comprehensive guide to help you get started. Now, what is Docker? I already told you. It's a platform that allows you to package applications and their dependencies into containers, making them portable across different environments. This is a platform as a service. Remember that. The key concepts include images, containers, Dockerfile, and Docker Compose. So what is images? If you look at it, and I'm just making sure that my live stream is working. Please create a Docker and Kubernetes playlist. So yeah, we are basically learning to, from the scratch beat. So we are starting out just completely scratch. Some like novice beginner doesn't know any clue about what Docker is and any clue about Kubernetes. This is exactly the stream, and this is exactly the series that we're starting. So you're in the right direction and in a right video. So remember, my prompt was I need to master Docker and Kubernetes for Windows 11. My platform was Windows 11. It doesn't really matter if you're in a Mac or anything. It still will give you information about it. So tell me all the information I need to know and give some practice exercises I can do within my computer. So this is exactly a good prompt that you should give. Docker is a platform that allows you to package applications and the dependencies into containers, making them portable across different environments. Then again, it allows flexibility. Key concepts is like images, containers, Dockerfile, and Docker Compose. Let's look at what all these things are. Images. It's a read-only template that contains the application code, libraries, and dependencies. Now, this is essentially just read-only, and you cannot update an image, right? And what is a container? A container, a runtime instance of an image, which includes everything the software needs to run. So that's whatever the software would need to run. It's inside of a container. Dockerfile, a script that with instructions to create an image. Now this is a file that we're going to be creating in a practical. So we're going to be doing this in the stream. And Docker Compose, a tool for defining and running multiple container Docker applications. So basically, a tool for defining and running multi-container Docker applications. um, very efficient and very like something that allows us to add, you know, multiple containers and then running them within this compose. So this is another, you know, component within the Docker ecosystem. Installation of Docker on Windows 11. Now, to install Docker Desktop for Windows from the official Docker website, what I would recommend is includes Docker Engine, Docker CLI, Docker Compose, and Kubernetes. These are the things, the components that we need. Um, Make sure that you install it from the official Docker website. So you just like Google search this, you would see the official Docker website, which is over here. Develop faster, run anywhere, build with the #1 most used developer tool, right? So you could just download any of the systems and it would accelerate how you build, share, and run applications. You build, share, run, verify, and test. And it's trusted by developers chosen by Fortune 100 companies. Um, provide develop Docker provides a suite of development tools, services, trusted content, and automations used individually or together to accelerate the delivery of secure applications. Well, 100 Fortune 100 companies. People, it's more famous of Fortune 500, but you know this is what Docker is, and it's being used widely across all the entire world. So basically, develop faster, run anywhere, build with the #1 most developer tool. The most used developer tool, and you could download Docker Desktop for your Mac, uh, for your Apple Silicon chip or your Intel chip. M1 chip is for this one. For Windows, AMD 64 or for ARM 64. And then we have for Linux. So I have the AMD 64, so I would choose this one. Essentially, I have Docker installation already done, so I do not have to show the entire process again. And then again, we thank the Stack Overflow community for ranking Docker the #1 most used developer tool. So, so you could see how uh, the benefits it provides, like speed, security, and choice. Now, if we go here, we'll ensure that our WSL2, which is basically Windows Subsystem for Linux, is enabled, as Docker Desktop leverages WSL2 for efficient operation. Now, I had Windows Subsystem for Linux. There's a complete process, what I showed in my earlier live stream. If you don't have Windows Subsystem for Linux, I would recommend installing this. Uh, would really appreciate if you go to follow this command about installing Windows Subsystem for Linux. It's a really good link to get this. So I would recommend doing that or watching my old live stream, which I had earlier, and it will guide you on how you could use virtualization and, um, and you know, essentially virtualization or what's it called, um, VM virtual machines simultaneously in your operating system. So Beat has another question where it says, and while please make the technical terms like containers, Dockers, package with easy words to make things more easier to understand. You do not have to worry at all. I go very simple and straight to the point, and that's what I keep. That's how I keep my videos. So that's why we're not gonna go that complex, and we're trying to, very understand everything very in a very simplistic manner, right? So what is this? It's just for virtualization if you want, adding multiple machines within your computer. So you need WSL2 installed. And I have it installed. I gave you the link if you don't have it, so just make sure it's added. Go into the BIOS settings. You press the F2, F3 key. Depends on what computer you use. I use that. I use at the moment I'm using a Lenovo all-in-one desktop, so that's why mine is either F1 or F2 as the BIOS key setup. After that, you have to enable the virtualization setting from there, and once you're done, you basically have WSL2. After installation, run Docker desktop and make sure Kubernetes is enabled. Optional for now, but useful later. So right now you don't need Kubernetes, but you know, essentially that's what you would prefer. So let's go and open up Docker because I have it, Docker desktop. Just gonna run it. And basic command, Docker commands that we should be knowing is like Docker hyphen hyphen version, check Docker version. This is for the CLI. Remember, Docker pull image, download an image from Docker Hub. Suppose we need the Nginx nginx, which is image. So we say docker pull nginx, docker run -d -p 8080 port 80 nginx. So this is run a container in detached mode. So that's why D starts exposing port 80. Okay, this one on container to port 8080 on host. So this is our port 8080 on host computer, which is our computer. Docker PS is list running containers. Docker stop container ID stop running container. All right, and then we have docker build -t name, and then tag build a Docker image from a Docker file. Now we're gonna be open up that 1 second. So Docker desktop, if I could open that up, so cross this out, minimize this, and yeah. So over here we have Docker desktop, just making sure that it runs. So it's sometimes slow, honestly, but yeah, we're essentially trying to add it within the system. If it doesn't work for some reason, I don't know, I might have to go into my Windows Shift and Escape, which is my task manager, and if I check if Docker desktop, just you could end the task from here, and then rerun it again. So let's try it out again. So for some reason it's not firing, right? And what I would believe is maybe uninstall and reinstall. Um, so yeah, so what I would do is I would go to the control panel, and over here uninstall a program, and you go over here, which is in my Docker. So essentially I have Docker desktop right here. So double click it, and it should it should work again. Any other questions so far before we move on to others? So one other thing I wanted to bring up is the way we're going about things. So suppose we have you know go here and we run a basic container using Docker run hello world. Describes your Docker setup. Simple app. Create a simple Node.js or Python. I'm using Dockerfile to package it. So example for Node.js. Now this is all good, right? We need to have this after installation run Docker desktop and make sure Kubernetes is enabled. We'll enable Kubernetes. Some basic commands to just know we're going to be using them. And hello world container. Run a basic container using Docker run hello world. So one other thing to test is if we have Docker within our system. Over here you can see I clicked on that removing VM and images. I believe we didn't have it, so if I use to type something like this, I'm not sure if Docker was recognized earlier or not. Well, it was because you had it installed. So you're uninstalling it, so it's taking some time. Um, it wasn't even pulling up. Fortunately, my system is a little slow, but with a moment of time, we would be able to list processes, locking Docker desktop resources, removing VM, which is virtual machine, and images. Hopefully, after a couple of time, it will be uninstalled and we'll reinstall Docker. Um, so this is basically the thing. The more we use applications, the more it has a load on the system. So right now we're done with that. And what I would encourage is installing Docker again. So Docker installer, I should have like an installer. If I go to my folder, which is over here, so we go to AMD 64, if we have one. Oh, sorry. So I downloaded it in the wrong place. Let me just cancel this. And 1 second. Um, so AMD 64. Go to the download section. So we have already one. If we could go and find out installer, let me see over here. So in the file explorer, the downloads, so we have Docker installer right here. So we've done it already back in 20. So I'm gonna double click it, and it should run it for us. Okay, so once I clicked on this installer, which is 5.4.3.3, 4.33.1, I activate the Hyper-V. 4.32. So which one is basically this one's newer. So let's cross this one out and just activate this one. So it's installing all these packages on our system, right? Allow it to unpack all these files, install a CLI and stuff like that. So we'll be waiting until all of this is unpacked. Once it's unpacked, we're gonna run it. I have virtualization option on, so I'm just gonna show you the entire process to just have it set up in our first live stream, or maybe we'll in the few further ones we'll add more processes. But yeah, this is going on. Just installing, setting it up. So yeah, it's unpacking file resources, bin, undock, all these kind of things, making sure all of these stuff are undocked or taken out of consideration. Yeah, I'll be just pausing a bit until it gets a little faster. But you can see over here, deploying components, create Docker, add user to Docker users group. So all of this process is happening. Uh, you can keep your messages in the chats, and I'll try to respond them. Once it's done, then we'll look at the other part. Yeah, so Docker is done installing, and we can close this safely. And now we can finally run it. So it should be like in our system again. If we go here and double click it, hopefully we'll give some time to it. It does take a bit of time, but I'm hoping it pops up anytime soon. There you go. So we have Docker subscription service agreement. And basically, this is an agreement where Docker provides some of the things that need to be like understood. The first thing is basically commercial use of Docker desktop at any company. So by selecting accept, you agree to the subscription service agreement, the Docker data processing agreement, and the data privacy policy. Commercial use of Docker desktop at a company of more than 250 employees or more than 10 million in annual requires a paid subscription. So yeah, these are some of the things that are looked for if we really want to understand it. So I'm just gonna update you. Just give me one moment. If you have any questions so far, we'll take a short break, but we're in the stream. If you have any questions about anything so far, let me know. Um, put it in your chat, anything like that, or anything that comes in your mind. So yeah, let me know. Waiting for any response. Hopefully after a couple of time it will be. Perfect. So we can now go forward, and I see that the Docker subscription service agreement, by selecting accept, you agree to the subscription service agreement, the Docker data processing agreement, and the data privacy policy. So commercial use of Docker desktop at a company of more than 250 employees or more than 10 million in annual revenue requires a paid subscription like a pro, team, or business. Then we have the subscription details. So we accept this, and you could add your work email. We recommend signing in with your work email address, or if you just have a personal email address, you could log in with your personal. I'll use Google to authenticate. So we'll just click on the Google logo. It just pulls up the account over here. So we could just log in with our Google account. So once we do, we'd be able to authenticate. So proceed to Docker Desktop. You're ready? Okay, so it takes us back, and once it does, we can wait until this loader stops loading, um, and then we could move on to the next part. So yeah, you could skip this, and just add the survey. It just ask you, and just say continue. Okay, and you could see that there's like an issue actually. Nothing. So some kind of issue, and Docker desktop -WSL is unresponsive, able to communicate with the Windows subsystem for Linux. Restart WSL and run Docker desktop again, or restart your machine for more information. The reason why this is not working is because my WSL might be off, so perhaps I might have to update it and put it back up and running, right? So this is a common error that happens a lot, and I know the fix for it, so I would recommend allowing it. But this is just, you can see a coding cleverly account. These are some of the containers. What is a container? How do I run a container? You're running containers. A container is an isolated environment for your code. View more in the Learning Center. You go, yeah, but terminal. I'll just give you an overview of the UI so far, and we could next time, look into it more detailed. Engine running, so you can see over here, you have something pause and then plus. Then we have quit Docker desktop. Three dots, add some more information like upgrade, account settings, sign out, and personal tier, change settings, download update, troubleshoot about Docker desktop, Docker hub. And then we have extensions and browse, manage, and create and settings. If you go to the Docker hub, it will take you to a link, And this is like develop faster, run anywhere. Docker Hub is the world's easiest way to create, manage, and deliver your team's container applications. So we have a lot of container applications like TensorFlow, official Docker images for the machine learning framework. Then we have PyTorch, is a deep learning framework that puts Python first. LangChain, building application with LLMs through composability. Llama is basically the easy way to set up and run with large language models. Now, if you go into any of these, which is in the Docker Hub, um, suppose if I open up TensorFlows, okay, just click on this. It's an image. So what I would do is I would use this pull command, docker pull TensorFlow, and this will have this image inside of my system. So running containers docker run it rm TensorFlow bash, start a CPU only container, and this is just for CPU. Start a GPU container using the Python interpreter. You could use this one. And yeah, basically you have an entire system and you could test your TensorFlow application. How cool is that? So Docker Hub has so much things. Let's go back, and we have more things like images. So our images are used to run containers. You can either build an image from a Docker file or download an existing image to run. So um, local, and this is the hub. So when you click on hub, you know, let's suppose I search one. So let's say if I search TensorFlow, where there's nothing actually. And then we have volumes. Uh, Containers can use volumes to store data. All data in a container is lost. Once it's removed, containers use volumes to persist data. So you could create a volume, persist your data between containers and multi-container applications. And we have builds over here, active builds and build history. So we have ID, name, builder, status, duration, created author, Docker Scout, subfeature, advanced image analysis with Docker Scout, where understand your application's dependencies, analyze the vulnerabilities, and act quickly with suggested remediation options. How to access advanced image analysis. This is just like for more visualization from the images view. Select an image to view its details. You could actually like get in more insight on your pipeline and your information about your, Docker image. Extensions. So we have a bit of extensions within the applet Docker desktop. And we have a lot of cool things about it. So Connect, Loglens, and Loglens filter and view container logs. So yeah, that's pretty much it. If you want to learn about a container, what is a container, I would recommend clicking on this. And you could basically learn from setting up your guide, create a simple project with your to explore what Docker Desktop can do, downloaded newer image for Docker. Welcome to Docker Desktop. So if I like allow access, unfortunately for some reason we had an issue with WSL, but over here you can see that we have a CPU percentage. So you can see over here RAM, engine total memory usage. This includes containers plus overheads. We have the CPU 1.49%. The RAM is 2.63%. Uh, Now you can see over here we started some kind of image which is called Welcome to Docker latest, and it's running on port 8088. If I click on this, it's running locally on my computer. Okay, so it says congratulations, you ran your first container. Now you have X, LinkedIn, and Reddit. Just click on any of these links, and they're gonna make you follow their page or something, or yeah. So you could actually post something like that. So yeah, I would tweet this. Although I don't have that much following, I would recommend following me on Twitter X. Coding Clever is there as well. Um, Anyways, what we go here is we have this nice looking confetti design, and this is our image. Welcome to Docker. It has its ID, so you can see over here, and it's in a container. So you can see the logs here. So you can see that these are some of the processes. What's happening? It's running 1 minute ago. You have inspect, okay, nginx, -g, daemon off, state. We have status is running, true, running, pause, false, and all that is all like in very nicely written code. Uh, and you can see that this is like a JSON format. So my bind mounts, exec, terminal, and then we have files. So you can see all these entry points, root, stats, and you can see over here your CPU usage, memory usage out of 5.75 GB. We're just using this much MB. You have not that much CPU utilization, 0%. Disk read write is nothing, 0 bytes, 0 bytes. And for the network I/O input output, we have a 6.87 KB out of 403 KB. Okay. If I go back and this is my image, I click on the image. So you can see over here there are some layers, right? So we have add file, and they added this file, which was 7.34 MB. After that, they used bin and sh label maintainer, which is nginx docker maintainers. After that, we have environment nginx version. We have package release equal to 1. We're adding some sets, add group, okay? Copying file, copying file, copying file, copying file, and copying file. After that, we have an entry point using a bash script. We expose 80, which was the port. We stop signal, sig quit. After that, we have nginx-g, daemon off, and then we have copy this build kit, right? To hash build kit. So these were some of the labels that were used, and push to Docker Hub. So we have command, copy -build, user, share, and that's basically, if you like select any of these, it will show you the commands that were being executed, right? One after another. It just creates this whole very nicely organized way of running this. Now you can see memory usage is 4.61 MB. And yeah, we have this Docker running. You can view the details, view image packages and SVEs, copy Docker run, open in terminal, view raws. Um, so you can see over here details like we mentioned. And you know, over here it's an image. So this is our image in use, and you know, it was created like it's saying 1 year ago. You can open up in a terminal and you know, use some commands, and that basically provides information about it. Any questions so far? I'll go to the chat and see if there's any. If not, then we're gonna move forward to the next part until we try to almost conclude it. So I believe my Windows subsystem for Linux did actually work at the end of the day. So let's work and make a hello world container. So run a basic container using docker run hello world. If I go to the command prompt, press exit, and cmd here, and I just type in docker -- version. I did uninstall it, but now I reinstalled it, so I have docker version 27.1.1. Okay, and then there was a build version as well. And run a basic container using docker run. Verifies your docker. This verifies your docker setup. So if I write that, I assume over here in the so over here, build a simple web app. Create a simple Node.js or Python app using the Docker file, and use a Docker file to package it. Example for Node.js. From Node 14, a worked app, copy package, run npm install, copy expose 3000, and node app. Yeah, build and run with Docker build, and then we have Docker run. Multi-container app with Docker Compose, created Docker Compose.yaml. So for this practice, we're going to be asking for, like, suppose the hello world one, right? So we'll say how to do this, not understanding the process, and it's going to give you more information on how to do this. So let's suppose we got two responses from ChatGPT and we choose one. So it's generating both. I'm going to prefer this one, so I prefer this response. So I got this. So let's suppose we follow this. No problem running a Hello World container is a simple way to verify your Docker is installed and running properly on your system. Here's a step-by-step guide. Open Docker Desktop. So we did open it up. Just 1 second before I get my drink. Yeah, so we have this Docker Desktop already done. So yeah, um, open Docker Desktop. Make sure Docker Desktop is installed. Is there anyone over here with any questions so far? Let's see, no one watching anything or have any questions? Okay, so let's keep moving forward. So open Docker Desktop. Make sure Docker Desktop is installed and running on your Windows 11 machine. You should see the Docker icon in your system tray at the bottom right of your screen. If Docker isn't running, open Docker Desktop from the menu. So the system tray basically is talking about this one. You can see Docker Desktop is saying running over here. Then open a command line. So open a command prompt or PowerShell window. So press Windows key and S. So Windows key and S. It basically opens up this, and within this Windows key and S, yeah. So type CMD or PowerShell and hit enter to open the command line. So essentially, Windows and S means search, and I could say command line. You could use PowerShell, but I like command line. So yeah, after that, run the hello world container. Type the following command and press enter. Now what does this command the Docker command line tool run tells Docker to run a container. The name hello world, the name of a simple Docker image that prints a hello world, hello from Docker message. Now Docker will check if you have the hello world image locally. If not, it will download it from Docker Hub, Docker's image repository. Okay, that's where all the images are. And check out the output. After running the command, you should see the output similar to this. If this happens, hello from Docker, this message shows that your installation appears to be working correctly. If you see this message, congratulations, Docker is running on your machine. What's happening in the background? Docker is pulling the hello world image if it's not already on your system. It creates and runs a container from this image, which outputs the hello world message. Once the container finishes running, automatically stops it. So we'll just say I don't understand difference between container and image, right? So let's see what it does. That's a common question. Understanding the difference between images and containers is crucial in learning Docker. Here's a breakdown. Docker image. Think of the image as a blueprint or template. It's a file that contains everything needed to run a program, including the application code, runtime environment, Python, Node.js, Java, libraries and dependencies, and configuration files. An image is static and read-only. It doesn't change unless you explicitly create a new image. Analogy, imagine an image as a recipe for baking a cake, okay? It has all the instructions, ingredients, and tools needed, but it hasn't been yet used yet. So basically that's an image, a recipe, okay? It has the application code, it has the runtime environment, libraries and dependencies and configuration files, but it hasn't run. Whereas a Docker container is a runnable instance of an image. When you create a container from an image, it becomes a live, isolated environment where the application runs. You can start, stop, and modify a container, but it's temporary. Once you delete it, any changes made into the container are also removed unless you explicitly save them. Containers are meant to be short-lived and disposable. Analogy, if the image is the recipe, the container is the cake you bake using that recipe. You can bake multiple cakes from the same recipe and each will be an independent usable item. So that's the most beautiful way of explaining it, as an image is just a recipe with all the application code, with all the runtime environments like Python, Node.js, and Java, with all the libraries and dependencies needed, and all the configuration files. And it's just a recipe which you can use to create more objects. And where what we're using is an analogy of a Docker container, which is a runnable instance of an image. Basically, when you create a container from an image, when you create a container from an image, it becomes a live, isolated, means alone, a separated, right, segregated environment that where your application runs. And the analogy here is if the image is the recipe, the container is the cake you bake into that, right? So image is the recipe. The container is basically the cake you bake using that recipe. You can bake multiple cakes, okay? You could make multiple containers from a single image, and each will be an independent using usable item. So example, when you run Docker run hello world, what it does is basically it pulls the image hello world, if not already available, creates a container from this image, runs the container which executes the code inside that image and displays a message. After it's done, the container stops, but the image remains, so you can create new containers from it anytime. Summary, image, a static file, like a blueprint or recipe containing everything needed to run a program, while a container is a live, running instance of the image, like a cake made from a recipe. It's temporary and can be recreated from the image at any time. I hope that all made sense and it was very simple to understand. Let's go back to our folders. Let's go back to our folder, which was YouTube 2024. And let's go back here and just refresh a bit. Uh, and what I'm going to be doing here is I'm going to go here and just type in CMD. And we're going to run the hello world command, right? Just so that we know that our Docker is working. So I hope you understood the difference between an image and a container. There was a question what Beat Mars had, and I hope that addresses his question, right? So thank you. Hope you understand where. Think of it as simple. An image is basically a recipe that you could use to make multiple containers, while a container is a runnable instance of that image. You can think of it as an analogy where image is basically a recipe, and a container is basically a cake that you made out of the recipe, right? And an image, it contains all the information like code, libraries, dependencies, and everything needed to run an application, whereas a container is the platform where you could run it and make multiple parts of it, add more configurations and changes, save it. If you don't save, you delete and remove it. They're temporary instances or live environments, okay, of recipes. So as a really nice example to it. Image again is just a blueprint. So over here we're going to type in docker pull, and then what we're going to be writing, oh sorry, not pull, this is another command, but we're going to be running this command. So docker run, and then we have hello hyphen world. Now remember again, what does this command do? It says pulls the image, which is hello world, if not already available, it would then create a container for from this image, and then after that it runs the container which executes the code inside the image and displays the message. So let's see what it does. So it says over here, unable to find image hello world latest locally. After that, you'll see over here um, pulling OM. So it's in pulling from library slash hello world. This is basically in the Docker Hub. It pulled completed. So it got an ID C1 EC31EB5944. This is a digest SHA 256. Okay. And then after that, status downloaded new image for hello world latest. And then we got a message over here. We ran it. The container runs. Hello from Docker. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. So it even gives some steps that Docker did. The Docker client contacted the Docker daemon. Okay. The Docker daemon pulled the hello world image from the Docker hub. So that's what I'm using. A Docker daemon is a piece of software that would go and check the Docker Hub for an existing image recipe of Hello World. Okay, AMD 64 because of my Intel. Now what happened is that Docker daemon created a new container from that image which runs the executable that produces the output you are currently reading. So that thing over here, right? The Docker daemon streamed that output to the Docker client, which sent it to your terminal. So the Docker daemon streamed that output to the Docker client, which was in my machine, and then which sent it to my terminal. So try something more ubiquitous. You can run on what am I saying? Ambitious. You can run an Ubuntu container with Docker run it -it Ubuntu bash. It would run a Ubuntu container. Share images, automate workflows, and more with a free Docker ID. So go to hub.docker.com. For more examples and ideas, visit this link. It's another good resource to learn. So here's this, and just paste it out here. Yeah, and it just gives you some useful things to do. If you're new to Docker, this section guides you, helps you with essential resources to get started. Anyways, this was a success. If you go to the Docker thing over here, if you go to the images now, you have two recipes, right? And if you go to the containers, would have two running containers. And it could look, it gives the name of a container. It has the hello world image on it, and it's exited, okay? And the same thing goes for this. When it's running, you could just turn it off. So we could say over here, pause or restart, um, and just stop it for if not needed. So that's how beautiful this is. And we're going to the next part, um, which is basically one more project before we end this live stream, and we'll go on to the next live stream to talk about Kubernetes. But let's suppose we go here. Yeah. So multi-container app with Docker Compose. Let's see. Okay. Uh, Give me more information on this. I don't understand how to do it. Okay. And you could tell how awesome AI is. It helps you so much, actually. So that's why I encourage all of my students to learn through AI. It is a game changer. It is so cool. It is amazing because a long time ago, I remember how Stack Overflow took so much time to update things. But now with AI, everything has gotten things have gotten so easy, and it just becomes very easy to learn. So let's walk through how to build a simple Node.js web application. Before I start this one, I'm gonna grab a water, but I'm gonna wait until if I have any questions from any viewer or anything like that. Feel free to share them. Would be appreciated. Yeah. I'm open for your answers. So yeah. Also, I mean, I enabled this insert ad. I mean, um, delay ads, create highlight video. Um, I don't know. So what I would recommend is, checking out these tiers that I added. Show your support for coding cleverly, engage with your audience. So yeah, these are some new features that I added, like stickers and stuff. So you could check them out. Yeah, so thanks. Yeah, so if you have any questions, you can feel free to leave them in the chat. I'm just eating some baby carrots. And we're going to the next part of this Docker series. We're making another project. We're making a simple node app, and then we're gonna run it and put it in a, container. Any questions so far, bro? Or guys? I think that's a no. So we're going back. Okay. So we're gonna be creating a simple Node.js web application. So before that, let me just finish my carrots. I really wanted to answer some questions. Please feel free to leave them down. Um, any experience with anyone who has done Node.js in the past? Let me know. Or anyone watching the stream who has any sort of knowledge of Docker or Kubernetes. Alright guys, let's continue. Finish my carrots. Create a simple Node.js web application. Create a project directory. Open a terminal or command prompt and create a new directory for your project. mkdir, which is make directory my node app. cd, which is my node app. After that, initialize the project. Inside the my node app directory, initialize a new Node.js project. We just initialize using npm init-y. That's very simple and easy and straight to the point. What we do is basically go into this desktop. We go to the YouTube 2024, and I know that this was for the Docker one, right? So I don't know, for some reason I could do something like Docker project, right? And what we could do is we could go inside here, okay, and go to the CMD, okay, and within it, remember, we type in npm So what I would do is I would put in VS Code because I just love the IDE. So once it's opened up, I would open up the terminal from there and visualize everything. It just makes it more simpler and easier. So over here we're gonna have delete, and then we have control and backtick. Okay, so you can see how you have Windows Subsystem for Linux installed on your system. Would you like to install the recommended WSL? And still, it keeps disturbing me. I'll just randomly install it. I'll say, okay, man, you keep disturbing me, so just get your WSL, open any folder, and it's installing. So I believe so. It open any folder in the Windows Subsystem for Linux and take advantage of this extension that is provided by Microsoft. It has a good rating, so just have it installed. Nothing like that. Just go back here, and in your terminal, you could type in npm, sorry, so npm init -y. This would initialize our Node.js, so Node app. So what we're going to be doing is it's going to wait until some process happens. Um, so just wait until it's done. After that, this creates a package.json file, which will store your app's metadata, which is information about your project, and dependencies, what it's going to be using. And then we're going to create an app.js file. So create a new file named app.js with the following code to create a simple web server. So this is like a web server that's so simple, it is super simple. Okay, so you could see over here, this would create our package.json file, and you could see how it echoed out what it contains. So it says it contains name Docker project, version is 1.0.0, main is index.js, scripts is basically echo or error, no test specified, keywords is nothing, author is this, list license is ISC, and then we have description, which is like blank, right? So this is exactly the same thing that was over here. Now what we're going to be doing is we're going to download or basically create, if I go here, and I could actually put it in the side, right side, and then just open up this one on the left. So what it's saying is that create an app.js file. So you could go here and to this and just say app.js file. Okay. And within the app.js file, what would you do is you would copy this and you would run it over here. So what is this saying is that there's an express require express. It's a framework, remember, for the backend. And then we have const app express. And then this is the port, which is on 3000. Now remember one thing, which is very important and important to understand. I have a complete Node.js, actually a complete series on MERN stack development, heavily detailed and explained in my channel. So go and check out my older videos if you want to understand how Node.js works. So we have app.get, and we have slash and rec and ris, and then we have response. These are request and response to the server. Response is from the server, and it says hello from Docker. And then we have a app.listen to port. Port is basically our 3000, and we're saying app is running on localhost, and then it just shows us this. So basic web server built. And this code sets up an express.js server that responds with hello from Docker when accessed. Okay, just with the default endpoint. Install Express. To run this app, you need to install Express as a dependency. So that's why you will add Express to the package.json file and create a node underscore modules folder with all necessary libraries. So if you look at this package.json file, if I go here into the control and backtick, and if I say npm install express, it would install our express package, and hopefully it would modify something in here. So let's see what it does. Remember, this is a framework for backend that helps Node.js operate. And there you go. You have 13 packages are looking for funding, and in the dependencies, Express has been installed, which is amazing. Now what you want to do is you want to see over here that we have under node modules folder, and it's a bulky folder. A lot of memes are created about it, and especially when you're uh, like putting this code on GitHub, you should ignore this one, right? Put in the env. It's basically not the env, but in the .git ignore to make sure that this is not added. And after that, once you do that, create a Docker file. A Docker file is a so actually, I think I didn't run it. So let me just make sure that this runs. So I could run this backend or web server using um, npm or npm no, npm I is basically for installing. Okay, after that we want to run it using node app.js. Oh, sorry. So we say node app.js. So app is running on localhost port 8. You can see over here. Click on it. So we can see hello from Docker, right? That means everything works as expected. Our web server is working. If I update it from here, so let's we don't have that. What is it called? What is it called? Node nodemon. So that's why like automatic refreshes don't happen. So what we have to do initially is we have to stop our server and then restart the server and then refresh. And that's why the change happens. So this is difficult, and that's why people normally like nodemon with it. So I save it, I have to turn it off, and I have to restart the server to see my change reflected. Um, yeah, but anyways, we have this web server up and running, and the next thing we could do is we could go to the um, you know, Docker file. To a Docker file is a text file that contains instructions for Docker on how to build your image. Okay, so now suppose in the this is our application dependencies and everything, right? In the my node app directory, create a file called named Docker file without any file extension and add the following content. So let's create an image, right? A Docker image with this for this all entire application because it has the source code. Remember, it has the dependencies and configurations all set. And what we need is just a file. And then this is a complete formula or basically a recipe. So Docker file. We're just going to type this in. Okay, you can see that it turned into a whale or something. Now what we want to do without any file and add the following content. So we have start from the Node.js 14 image. So start from the node. Now you can see over here, do you want to install the recommended Docker extension from Microsoft for the Docker image? You can install all this stuff. It just helps, improve the experience of code. So just, make sure you have all this. And look at code highlighting happens. Okay, so let's make sure we have this like this. And let's just copy this and paste it right here. Okay, start from the Node.js 14 image from Node 14. Start, and then we have set the working directory inside the container. So, we have all of this pretty well defined. Well, I would ask one thing is how would the directory structure look like? So I would say, how would the directory structure look like for my MERN app? Okay, or sorry, Node.js app. I have a folder, okay, called which one is it? So it's called Docker_project. I think so. Look over here. Yeah, this is not it. So go over here, right click, and reveal in File Explorer. So there's a file called Docker-project. Inside we have all this stuff. So Docker-project, and inside it contains app.js, package.json, and Docker file. what is the hierarchy? What is the hierarchy or project hierarchy? Something like that. Hierarchy, like that. CHY. Okay, let's run that. Your directory structure sounds well organized. Here's what the directory hierarchy should look like for a simple Node.js Docker project. Okay, so what you would have is basically a Docker project. Inside you would have the app.js, main Node.js application file. We have the package.json Node.js package file with metadata and dependencies, right? Application file is this one, app.js. And then we have the Docker file, which is Docker file with instructions for building the Docker image. All right. After that, we have building the Docker, recipe basically. Example directory hierarchy to illustrate. Here's how each file fits. So we have the Docker, the root folder of your project. Optional additional files. You have the package-log.json, automatically generated by npm. This file locks down the versions of installed dependencies. And we have the readme.md optional file to document your project. So the structure with these optional instructions should look like this. We have the lock, auto-generated, and then we have optional documentation. Anyways, we have a good hierarchy so far, so everything looks good. Let's go back to this Docker file. So what it says over here, it says that in the my node app directory, create a name called file named Docker file without any file extension and add the following content. So you can see over here we have start from the Node.js 14 image. So we have Node 14 image, okay? Set the working directory inside the container. After that we have work directory /app. After that we copy package the JSON and package-log.json to the what? To the container. We have copy, package, whatever after that, whatever it contains, and and we want to copy it to the container. After that, install dependencies, npm run npm install. After that, we have copy all files from the current directory to the containers app directory. So we basically have a container folder called app, which has all the content, basically all files, and we just copy everything inside this folder. You see all this stuff is being copied from here to the containers, to your app directory. Expose port 3000 on the container. So we want to expose 3000 port on the container. And then command to run the app when the container starts. So this is a command to run a node and then app.js. Okay. And again, I explained it, so you could just see read it over here from node 14. Start from a Node.js image. With version 14, this image includes Node.js and npm. Work directory app. Set the working directory in the container to /app. So that's the working directory that we need for the container once it's created. So we have a package. Copy the package.json and package-log JSON files to the container. This ensures npm installs the correct dependencies. This is very important because we need the dependencies making sure everything is matched within the container. Run npm install is run npm install in the container to install the dependencies. And then we'll copy all files from the current directory, which is your local app, to the container /app directory and expose the make port 3000 available outside the container. And then we want a command to run Node.js application when the container runs. Now build the Docker image. In the terminal, make sure you're still in the my node app directory. So build the Docker image, and this is one of the easiest ways to build. To build a Docker image, right? What you want to do is you would my node app directory. Make sure you're still in the directory, the same home directory. Build your Docker image by running. So this is basically our Docker image, remember? This file, Docker file, and this is our image. So what we want to do is we want to build the Docker image. So what we say is go to this command. One second. So if I go here, cross this one out, and go here. So I go dir Docker project. So cd Docker Okay, okay, so over here inside Docker project, we could run our Docker image. Okay, build your Docker image. Sorry, not run, but build. So we say Docker build. Okay, -t, and it's called Docker project, right? The folder name, and then we have dot. So let's see the explanation of these commands. So the first one is Docker build. What does Docker build do? This command, the command to build a Docker image. Okay. After that, we have -t, and then Docker project. What is it? Tags the image with a name, my node app, for easy reference. Oh, okay, got it. Instead of the folder name, right? Sorry. Okay. Oh no, so my bad. So Docker build. So we make sure we're in the directory, and then after that, -t, we have tags the image with the name my node app. Okay, for easy reference. And what is the last one? Dot specifies the build context as the current directory where the Docker file is located. Okay, build context is where the Docker file is located, and Docker will follow the instructions in the Docker file, pulling the Node.js base image, okay, copying files, installing dependencies, and packaging everything into an image named my node app. So when I press this enter, you'll see some magic going on. Um, After that, okay, you can see over here building 1.7, internal load build definition from Docker file, transferring Docker file, internal load meta from Docker, all this happening, all this stuff happening. And you could see over here we have a building 17, 18, 19.2 seconds, 21, 5 out of 10. Um, and my fan is starting to run from docker.io/library/node. It's getting the node image, okay, from the Docker hub. I remember using Docker daemon. So, it's building, let it build. It stopped, it little froze here on 26.4 seconds, 5 out of 10. Transferring context, 5.25, 2.25. So it's just gonna keep going, hopefully. Okay, I pressed Control C, unfortunately. The reason is because sometimes it like stops and then I just press Control C and it starts again. So building 67.8. Let it just build for the time being. Once it's done, we know that our image has been built successfully, right? So remember that Docker file, the 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 file with the capital D and OCKERFILE, which has the information on how we're gonna be building our Docker image. That's basically the recipe that we're trying to build, and hopefully this is gonna build it for us, the image. So, oh, I wasn't expecting it building above 100, so it's going 106. You can see, and there you go. We have a working directory app. Okay, for our container, it will be our working directory copy package. So it's copying all the contents and exporting to image. After that, it's writing layers, writing image, and then we have view build. Amazing, amazing, amazing. We have it all completed successfully. Okay, so now that's really cool and everything seems to be done. What we have here is, so to be honest, like everything was all over here, and we run the Docker container. Okay, so we basically build the Docker image first. That was our image that we built, and then we run the Docker container because now everything seems to be ready. And you know, this is basically the app directory, right? Slash app. Set the working directory in the container to app. So this is our working directory, and now we just have to build our Docker image. Sorry, build the Docker image. So the first thing we did was create a Docker file, build the Docker image, run the Docker container. Once the image is built, you already have it built, you'll can create and run a container from it. So you already have an image built, right? So this was just the file, Docker file. We successfully built our image, and now you can create and run a container from it, right? Because now we could run a container and create it using that recipe that we've already built, the recipe. Run the container with the following. So we have run, so this command will run our node app. So Docker run starts a new container. After -d runs the container in detached mode, meaning it runs in the background. After that, we have -p 3000 port 3000 maps port 3000 on my computer to port 3000 in the container. This allows you to access the app in your browser. And then we have a my node app. This name, the name of the image to create the container from. So let's run this Docker run -d, which is in detached mode, so that it's running in the background. -p, so maps your ports. So it's 3000 from my local computer to the port basically in the container. Maps 3000, maps port 3000 on your computer to port 3000 in the container. So port 3000 in the container. So we have my node and then we have app. This was my node app. Press and run. You'll see over here it's done. So what's going to happen now is that access the app. So if you go to localhost port 3000, so one second. If I go to localhost port 3000 right here. Oh, sorry, right here. This is basically running from the Docker container. Open a web browser and go to localhost port 3000. You should see hello from Docker displayed, confirming that your app is running inside a Docker container. Why? Because the app is off from here, okay? And it's running from a Docker container now. Amazing. If you go to the Docker, it's already created too, and it's this one. So my node app is running on that 50 seconds ago, and it's running. It's a container. It's a running instance of an image that was already created, which was hello world. Sorry, it was my node app, and it's beautifully done. Basically a Node.js application running. Stop and clean up. When you're done, you can stop the container and remove it if needed. So list running containers. If you do docker ps, it would run the containers. So if I say docker ps, this command will show a list of all running containers, including the container ID of your my node app. So all the running containers are like these. So if you see over here, so we have a container ps, so we have container ID. There were two basically, image, my node app, and the welcome one, right? So you could see the command and the created and status, ports, and names, right? Now what we could do is stop the container. So if you want to stop a current container, you could use the container ID to stop it. Replace container ID with the ID of your running container from the docker ps output. Remove the container, optional. Remove container, this deletes the container itself, but leaves the image intact so you can run it anytime. Summary, here's the entire process from start to finish. Create a Node.js app, write a Docker file with instructions to build the app image, build the Docker image with docker build -t my node app dot, run the image as a container with the docker run -d -p, right? After that, we have this website to see your app running. Stop and clean up your container once done. This exercise gives you hands-on experience with Docker's build, run, and image replace management process. You can also try modifying the app.js file and rebuilding the image to see how updates work. Let me know if you need further clarification of these steps. So that's beautifully done. Let's just stop our container, both of them. So I'm just going to use the container ID right here. copy it, and I'll say docker stop, and then the container IP. I think that's how you do it. Yeah, so container ID, this one, and we're gonna stop the my Node.js one, and it should stop it a couple of times. I'm hoping it does. Okay, it stopped it. Awesome. It just prints out the same thing. So if you do docker ps now, you'll only have one. You see that? And now let's stop with the other one. So we'll say docker stop, and then we'll stop the welcome to Docker image as well. Or sorry, not image, but container, because these are showing, running containers. So now that's stopped, and if I do docker ps, not gonna show anything. Okay. What does docker ps mean? So I think it means like the docker ps is used to list running Docker containers on your system. It shows important information about each container, such as the container ID, the image, the command, created, status, ports, names, common variant of docker ps-a. So use docker ps to monitor your containers, check their status, and see how they are configured. What does ps mean? Okay. So if we look at Docker, what does Docker PS stands for process status. It originates from the Linux command ps, which displays information about active processes on the system. In the context of Docker ps process status shows the processes or containers that are actively running, right? The command is similar to the in concept to ps in Unix, Linux, but specifically tailored to manage and monitor Docker image container. So that's basically called process status. That's pretty nice and pretty awesome to hear. There's one more project that was mentioned. This was the Node.js one, but then there was one more. If we go on the top, yeah. So it was a multi-container app with Docker Compose. So create a Docker compose.yaml file to define multiple services, web server plus database. And then after that, we have run using Docker Compose up. So we'll say more detail on this, right? Can you give me more detail and information on this? And then it would give us the the entire process on how to do this. It will, so this would be for our next part. So far, this is the live stream. If you have any questions, leave it down on the chat. If not, we're closing this live stream and we'll be continuing further with this other project from Docker, and then hopefully we're also going to be talking about the Kubernetes. But before that, I'm just going to delete my containers as well. So the containers are stopped. So common, yeah. So what does Docker PS mean? But before that, okay. So okay. So I mean that's pretty much it. If you go here, I think it was Docker remove or something. Docker PS process status nothing. If you go here to my containers, you go to the containers, and you can see over here they're all exited. Okay. And if you look at the images, they're still there. You go reuse them, and you go push to Docker Hub, view packages and CVs. But yeah, that's pretty much it. We're gonna be talking more in detail in a later video, but I hope you like this one. Thank you and peace out.